Hello, Hornets. Welcome. Today we are going to be looking at P-series and convergence. And I want to make sure that we recognize that there is a distinct difference between the summation P-series starting at n equals 1 and going to infinity for 1 over n to the p. And this is not the same as the integration from 1 over n x to the p dx. Please be aware these are very different, and we'll be talking about this, not this. This is improper integrals, and this is sequence series. This is series. So it's very important that you recognize that we are not talking about these. All right, these require us to look at it in a slightly different way. Let's just review that real quickly. I'm going to take an example or two. Let's just look at this example, please. We're going to go through it very quickly. According to our rules, because I have a harmonic series, we know harmonic series for integration always diverge. But when I look at the next one, you'll notice I end up with 1 over 2 to the x. And this is now an exponential growth, and that require us to actively go through the integration to check, but it is most likely converging. We know that because I can look at it as 4 times 1/2 to the x power, and now I'm looking at a geometric series whose ratio is less than 1. In number 3, you'll notice we're approaching 6 as an asymptote from both directions. And because I'm going from 7 to 6 and 2 to 6, I know that both of these are going to diverge because my power is greater than 1. In number 4, you'll notice right here I have now a situation where my power is less than 1 and approaching the asymptote from both directions, and therefore I know that number 4 will converge. And you'll notice we're talking about it in terms of the power and approaching the asymptote or approaching infinity. That is not the case when we are talking about a p-series. For example, the p-series can only go to infinity. This is because we're dealing with a series. So we're never going to have that situation where we approach our asymptote. So let's just take a look and see what we have. This is what we refer to as a p-series. We saw it with the integrals, but now we're looking at a series righteously. And we can see that 2 is greater than 1. As we approach infinity, this must converge. Now you'll notice it's already satisfied the first test, and the first test was the nth term test. Does the limit as n approaches infinity for 1 over n squared go to 0? And the answer is yes. This is the case with all p-series when we are dealing with a positive exponent in the denominator. We can see that by Feppel and work with it. So we now are looking at the situation where we have the p-series, and the p-series works like this. If p absolute value is less than 1, let's just get rid of the absolute values and call it OP for what it truly is. If this occurs, then the p-series diverges. However, If the P is greater than 1, then the P series converges. Whoops. The P series converges. So this is one of our simpler problems that we have, or processes that we can work with, because all we have to do is look at it. Here, let's take an example. The summation as n starts at 1 to infinity of 1 over n to the 3/2 power. All you have to do is look at that exponent, 3/2, and recognize that 3/2 is greater than 1. Because 3/2 is greater than 1, this series converges. Now you'll notice I already knew that my nth term test had to pass. It's a P series, and so I can automatically look at it and say, well, since I have 1 over n to the 3/2 power for the limit as n approaches infinity, I get 0. So both conditions are working, and the P series must converge. Let's look at another one. The limit as n approaches infinity for 1 over n to the 1/2, which is going to come from the series n equals 1 to infinity of 1 over n to the 1/2. Does this converge or diverge? Well, our first piece goes to 0. It satisfies the condition, but because the P equaling 1/2 is less than 1 and greater than 0, OP, we have a divergence. And that's what we're doing. Do we have an OP, in which case we have a divergence, or do we have a P greater than 1, where we have a convergence? This is the convergence divergence of a P series. Thank you very much. I hope this helped, and please watch it again. If you have questions, please bring them to me. Thank you very much.